Now, what I've shown you so far is still not the version of the fundamental theorem as you may remember or as you keep using it all the time. So let's look at that version, which is the practical version. Okay, the practical version says the following. Let's say you have a continuous function f of x. Okay, then if you pick any one of its antiderivatives, then the area under the curve little f of x between a and b is going to be given by the difference of the values of that antiderivative at b and at a. So I'm sure this one is the formula that you have seen before and the one that you're going to be using all the time. But again, notice what it actually says. The definite integral, which is an area, can be written down in terms of antiderivatives. Okay? And this is the crux of the fundamental theorem, or the core of the fundamental theorem. Okay? So remember that the integral from a to b is the area under the curve between a and b. And so this gives us a very simple way of computing that area, bypassing altogether or that limit and summation thing that was involved in the definition. If you go back to the definition of definite integral, that involves a limit and a summation. This statement here says don't worry about any of them, just compute an antiderivative, evaluate it at the two endpoints and subtract, and you're done. So let me give you a sketch of the proof of this practical version, a proof that actually relies on the theoretical one, and that's the other important reason for you to understand the theoretical one. Let's see how it works. So this is what we want to prove, that the definite integral from a to b of f of x dx is the difference between the two values of any antiderivative at the two endpoints. Remember, what we know so far is that the area function is one antiderivative for the integrand. Okay, so f of x is the derivative of the area function, so a of x is one antiderivative. The point is which one. Okay, all right, so what we're going to do, let's pick any antiderivative. Remember that the statement of the FTC does not specify which antiderivative we need to pick. Just pick any one. Okay, so let's say capital F of x is any antiderivative of little f of x. Okay, so that means that a of x, being one of the antiderivatives, is going to be different from f of x just by a constant. So a of x is going to be equal to f of x plus c. But how much is c? Turns out we can compute it very easily. All we have to do is compute what a is at a, which is, remember, the lower limit of integration. Well, the area function at little a is going to be equal to the integral from a to a of f of x dx. Well, that sounds kind of silly, but turns out to be very useful, because on the one hand, we know that because the area function is equal to f of x plus c, that means that the area function at a is going to be f of a plus c. On the other hand, we know what the answer to that is. Well, it's going to be 0, right? The left and the right limit are both, or the upper and the lower limit, depends on how you want to call them, they're equal. So that means that the area under the curve from a to a is 0. Well, those two numbers therefore have to be the same, and it implies that my c is going to be equal to minus f of a. Alright, so that means that my area function is actually f of x minus f of a. And that's going to be true for any value of x, right? So in particular, it's going to be true for the b that we had to begin with, right? So the area function at b is going to be equal to f of b minus f of a. But remember, what was the area function? The integral from a to b of f of x. Okay? So this may look like we're running in circles and trying to prove that the water is wet. But remember that one of the reasons why you may have that feeling is that you have used this theorem so many times, probably accepting it on truth, that you're not realizing how many things were left unsaid about it. Okay? So try to follow this proof again if you have to, if you want to, if you have to. You may not want to, but you may need to, and make sure that you understand what the basic ideas, what the basic steps are, and why it is important to follow them.